Hello, this is Doug Clement, and this is Thermodynamics problem number 7, calculating the enthalpy of formation of acetylene. So in this problem, we will calculate the formation of enthalpy of acetylene by identifying which reactants combine to create acetylene and manipulating these three equations so that the product of the net equation is acetylene, and by manipulating the change in enthalpy values along with what we do to the equations. So, to start, we are asked for the formation of acetylene. So that is the key word because in our net equation, we will have acetylene on the right side. So we know that to form acetylene, we will have C2H2 on the right, and forming that will be 2 carbon and 2 hydrogen gas. And we know that's hydrogen gas because in our equations we can see we have hydrogen gas right here. So, starting with the first equation, we see that we have solid carbon plus oxygen gas creates carbon dioxide gas. So, we know that in our net equation we need carbon, and we have 1 carbon in our first equation. But in our net equation, we need 2. So we know that we're going to have to multiply this equation by 2. So this will be 2 carbon plus 2 oxygen gas creates 2 carbon dioxide. And whatever we do to our reaction, we also do to our enthalpy. So we're going to multiply that by 2 as well, and our new change in enthalpy will equal negative 787 kilojoules. Also, all of the units we will be using for this problem are kilojoules, which are units of energy for change in enthalpy and are equal to 1000 joules. So now we'll go to our second equation. So in this equation, we can see that in our reactants, we have 1 mole of hydrogen gas, and in our net equation, we need 1 mole of hydrogen gas as well. So we're going to leave this equation alone for now. So we'll have hydrogen gas plus 1/2 oxygen gas create H2O liquid. And then we'll go to our third equation. Oh, and the change in enthalpy for this will stay the same because we didn't do anything to the equation. And then we go to our third equation. You see that our goal net product, acetylene, is on the left side, but we're trying to calculate the formation of acetylene, which means we need it on the right. Also, we can see that we have 2 moles of acetylene on the left when in our net equation we only need 1 mole. So, to manipulate this equation, we need to flip it, which will flip the sign of our change in enthalpy. We also need to divide it by 2. So, when we do that, when we change the sign over here and divide it by 2, our new change in enthalpy will equal 1,299 kilojoules. And our equation will change to H2O liquid plus 2 carbon dioxide gas creates 1 mole of acetylene plus 2.5 moles of oxygen gas. So now that we've finished that up, we can start canceling out what we don't need. So we know that we need 2 carbons, 1 mole of hydrogen gas, and 1 mole of acetylene. So everything else we can start to cancel. So we can see that we have 1 mole of water we can cancel, 2 moles of carbon dioxide that we can cancel, and 2.5 moles of oxygen there, and 2.5 moles of oxygen there. which leaves us with 2 moles of carbon, 1 mole of hydrogen gas, and 1 mole of acetylene, which gives us our net equation we were aiming to get. So, now that we've done that, we can take our new changes in enthalpy that we've calculated and use this equation where the change in enthalpy of formation of acetylene is going to be equal to the sum of all the change in enthalpies of all the reactions we are provided. So, if we do negative 787 kilojoules plus negative 285.8 kilojoules plus 1299 kilojoules, the change in enthalpy will equal 226.2 kilojoules. Lastly, using proper significant figures, if we go to our original enthalpies right here, using addition significant figures, we know that we need to round to the least amount of decimals used in our 3 original enthalpies. So if we go through them, we have 1 here, and 0 on this one right here. So we need to round our answer to 0 decimals using addition significant figure rules. So our real answer will be 226 kilojoules. So in this problem, where we were asked for the formation of acetylene, we were able to manipulate our equations and do the exact same manipulation to their corresponding changes in enthalpies based off of the net equation that we were aiming to get, which was written down here. And then when we found all of the changes in enthalpies, we were able to sum them up and find our answer using addition significant figure rules. Thank you.